Benda ni memang sengit ni. Dekat sini. Okay, Assalamualaikum and good morning to everyone. Syamimi, now I can see here. Hari tu awak tak datang kelas ke Syamimi? Hai, kelas pun forgot. Okay, please don't forget to take your attendance for today. Okay, so who is missing now? 2 students are missing. Is Seri here?
Ada, Doktor.
Seri ada, okay. Siapa yang tak ada ni? Najib ada, Muhammad Najib?
Ada, Doktor.
Muhammad Anas? Muhammad Anas.
Ada, Doktor.
Okay, Muhammad Faidi. Amirul Hazmi, ada Amirul Hazmi?
Ada, Doktor.
Nur Karina tak ada. Okay, Safwat Amina.
Ada, Doktor.
Safwat ada.
Saya ada, Doktor.
Muhammad Hasif Mahazir. Nurin Natasha.
Ada, Doktor.
Ada.
Tanzilin.
Yes, Doktor.
Farah Hanani. Wan Nur Adlin.
Ada, Doktor.
Yan Muhammad Akasyah. Akasyah ada. Mama Akasyah ada? Akasyah tak ada lagi. So 2 orang. Okay. Sekejap Ada. Okay, so can we start now? Present. So did you join the the talk last night? Road to career or whatever, apa benda ke? Join tak? Did you join last night? It's very interesting, right? Okay, so wait, mana dia shopping? Register, okay. Okay, now can you see the slide? Okay, good. I only hear Syamimi. What happened to others? Okay, Syamimi is good. Very, respond. Good respond. What about others? Are you here? Okay, this one, have you done the circuit? This counter? Dah, okay, very good. So you got this kind of circuit, right? Dapat tak?
Dapat.
So make sure you know how to draw the counter. Start from the state table. state diagram, state table, and then do all the K map and everything, and then come up with this circuit. Okay, there is always question in the test or final. I'm not sure yet. Okay, so have you done this one?
Doktor,
Ya.
ada orang nak masuk.
Siapa? Akasha?
Ya.
Dah, lagi seorang? Ada lagi? Okey, dah penuh. Sekejap tengok dah penuh ke belum. Satu lagi. One more student. Siapa tadi saya panggil? Nurul ke apa? Nur Kairina Nur Karina. Okay, so where is my slide just now? Okay, here. Okay, have you done this one? Have you done this question?
No.
Okay, now try to do this one. Take a piece of paper. Okay, you need to practice how to design counter. Okay, take out a piece of paper and then do this one. Start with, this is called the state diagram. Okay, so this number in this circle is called the state. That is 0, 0, 1. Okay, and then this arrow show the transition. From 0, 0, 1, it goes to 0, 1, 0. And then from 0, 1, 0, the next state is 1, 0, 1. And then from 1, 0, 1, it goes to 1, 1, 1. And then from 1, 1, 1, it goes to 0, 0, 1. So the state diagram is already given. Then you must come up with the state table. Okay, do you know how to do the state table? State table, you must have present state and then the next state. This one we have discussed last week. This is the state table. Okay, you must have present state and the next state. I want you to have this kind of number. Okay, see, where is Q naught here? Okay, here is Q naught, Q1, and then Q2. So you only have like 0, 0, 1 just now, and then 0, 1, 0, and then after that 5, right? 1, 0, 1, and then 7, I think 1, 1, 1. Okay, from 0, 0, 1, it goes to 0, 1, 0. So you must have this present state and the next state. Tell me when you have finished. I give you only 5 minutes. Amina, have you finished?
Not yet, Doctor.
Okay, you only have 4 state only. Yeah, you can list out all also, but the number which is not in this state, you can just put dash 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 later on. Okay. Okay, and then check what is the next step to do after that. Okay, after you have this present state and the next state, then you draw the K map. Okay, so for this example, let's say you use JK flip-flop also. So how many cells do you have for the JK flip-flop? You must have 8 cells because there are 3 bits, yeah? You have 0, 0, 1, there is 3 bits, so you have 8 cells. Okay, then you can fill up all the state in this K-map. Okay. What is the transition table for JK flip-flop? It's here. This is the transition table, yeah? So you must know how to do this. Muhammad Izzat, have you finished?
Not yet.
Wih, lamanya. Okay, this is already done for you, but I want to see the table first. The state table. Aman Iqbal dah siap belum?
Belum, doktor.
Tengok buat sekarang. Tunjuk kat saya. Tunjuk kat kamera ni. Awak tunjuk kat kamera ni. Aiman dah buat? Belum? Amina? Amir Sufi, have you finished?
On the way, Doctor.
On the way, which one?
State table.
State table? Dah siap belum? Lamanya. Aiman Iqbal, have you finished?
Sikit lagi, doktor. Kejap.
Mama Imran dah siap? Finish Mama Imran?
Sikit lagi doktor.
Puan Adriana dah siap?
Andui.
Dekat mana sekarang?
Dekat KMAP.
Oh, dekat KMAP dah. Okay, Tan, have you finished Tan?
So I'm doing KMAP.
You're doing KMAP. Okay,
Yes.
good. What about others? Are you on the KMAP already? Seri?
Dekat KMAP doktor.
Okay. Okay, Seri. Show me your answer. I want to see the state table first. Seri?
Ya doktor, sekejap.
You can WhatsApp me. I mean in the group. Okay, 2, 2 to 3, 5, 5 to 7. Okay. Okay, good. Normally, if you have done the state table correct, okay, you can easily do the K-map. Okay, remember K-map, you must refer to the present state, and then when you want to fill the cell, you look at the transition. Let's say for Q0 from 1 to 0. Okay, so then you look at 1 to 0 at the transition table of JK flip flop. Okay, what is the value? Either 0 or 1. Okay, so now let us continue. What about the rest? Have you finished? Tan?
Doctor, sir, still on the way.
Still on the way?
The K-map doing the last part.
Oh. Seri, have you finished with the circuit?
Circuit belum.
Draw the circuit. From the K-map, you simplify the equation. Okay. And then you draw the circuit. finish? Finish. Okay, have you finished? So this is the K-map. I continue, okay? The K-map, you should get this. Okay. This one for J2, J1 and J0, and then here is for K2, K1 and K-map, right? Sorry, K0. So since this is a 3-bit, you have 3 flip-flops. So you can do the grouping. For example, you get here Q1, okay, because this cancel here and here, so you have only Q1. Here you take the whole cells, so this equal to 1. Here also you take the whole cell, so this also equal to 1. Can you see my slide? Hello?
Yes, doktor.
Okay. And then for K2, see you take this cell, 4 cells here, this grouping. So Q0, you can eliminate, Q2 also eliminate, so you have Q1 here, and then here you take the whole cell, so this is equal to 1, and here you take here, okay, Q1 is eliminate, Q0 also eliminate, so you only have Q2 bar, right? So from here you can draw the circuit. So you have here J0, J1 here and K1, here J2 and K2. So how do you draw this? You must look at this, look at the K-map here. So here is equal to 1. See, J0 equal to 1. So the input of the J0, so you look at here is J1, J0 is high because 1 is high, right? Okay. Now you go back to, see here, K0 is equal to Q2 bar. So you look at here, K0, Q2 bar. Where is Q2 bar? Okay, here this is the Q2 bar. So Q2 bar is connected to K0. Okay. And then look at the J, sorry. Look at the J. J1 is 1. K1 also 1. So look at the circuit. J1 and K1 connected to high because both are 1. And then you look at J2 and K2. J2 is Q1, K2 also Q1. Right? So this is J2, K2 and Q1. This is Q1, so both are connected to Q1. Okay, so this is your circuit, and then you design using this is synchronous or asynchronous circuit? Tell me.
Synchronous.
Okay, this is synchronous circuit because you only have one clock applied to all flip-flops. Okay. Okay, now we go. Everybody finish, eh? Can I move on to next slide?
Yes.
Okay, now this is a different type of counter. This one is a 3-bit up down gray code counter. Okay, up down meaning you have one counter is counting up and then the other one is for counting down. Okay, designed in one counter circuit. Okay, so now look at this. state diagram. Okay, remember this is the state diagram. So state diagram here it shows from 0, 0, 0 goes to 0, 0, 1. Now look at this y equal to 1 first. Y equal to 1, this refer to counter or count up. Okay, up counter. Y equal to 0 is down count. Okay, down counter. Because y equal to 0 is down count because from 0, 0, 1 it going to 0, 0, 0. It's going to a smaller number. Okay. If y equal to 1, this is up count because from 0, 0, 0 it goes to 0, 0, 1. 0, 0, 1 goes to 0, 1, 1. 0, 1, 1 goes to 0, 1, 0 and then goes to 1, 1, 0, goes to 1, 1, 1 and then goes to 1, 0, 1, goes to 1, 0, 0 and then go back to 0, 0, 0. Okay, and down count you see here from 0, 0, 0 goes to 1, 0, 0 goes to 1, 0, 1 and then goes to 1, 1, 1 goes to 1, 1, 0 and so on. It goes back. So this is up and down. Okay, if you want to design, this will be a huge, circuit because you have for Y1 and Y2. So in the state table, you must have 3 bits for the state here. And then you must also include Y equal to 1 and also Y equal to 0. Okay. Where is the state table? How do you do that? Okay, now you must, this is not given to you. Can you do the state table for this one? Hello?
Can, Doctor.
Yes, doctor.
Okay, so do the state table first. So you have here, like, for example, you have A, B, C, or 0, 1, 2 lah. 1, 2, 3. 0, 1, 2. 0, 1, 2. And then Y equal to 1. And then Y equal to 0. Make it different column, To avoid mistake, you make it like 2 state table. 1 for Y equal to 0. 1 is for Y equal to 1. Can you do that? Make it 2 different state table. So you won't make any mistake. Finish?
Belum.
Belum. Okay. Ada pembaris tak? Ada pembaris tak? Panjang ya? Okay, it's better if you do this way. Okay, look at my table here. Okay, so you can list this equal to 0, 0, 0. Okay, now here is 0, 1, 0, 1 and blah 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 0, 0, 1, 1, 0, 0, 0, 0 and so on. Okay, here is 0, 1, 0, 1. It's all equal to 1, 1, 1, 1, 1, 1, 1, 1. Okay. 0, 0, 0, 0. Okay, 0, 0, 1, 1. 0, 0, 0. Okay, you can also do this way. Okay, for example, this one. Okay. Because remember, in the K map, you will have 4 cells. You use 4 variables. So you have 16 cells. Okay, because you have Q2, Q1, and Q0, and also Y. You must include. Okay, so and then the cells in the K map refer to the present state. Okay, do you have any question? Okay, so you can try this one at home until you get this. We get this. So this is J and K map for up-down control input. So Y is treated as a fourth variable. So you must treat Y. You cannot use the 8 cells because Y included there. So that's why I prefer if you use this, the table that I have shown to you, because that include the Y also. So you won't miss it. Okay, any question? Sekejap, saya nak fikir betul tak saya buat ni. 000, so 0010, 0001, 0001, where Y equal to 1. Okay. Okay, 001. Okay. But it's also depends on you which one, how you want to, to do the table. Even for example, the one that someone who sent just no Hasif, okay. Hasif sent just now also can, but just don't do mistake when you put the number either 0 or X or 1 in the cells. Okay, Hasif? Hasif?
Okey, doktor.
Faham
Faham.
So either way is correct. Either you want to use your own state table here, or you want to follow me, it's okay. Okay, as long as you won't make any mistake when you put all the values in the cells. And then from there you do the grouping. Try to find the minimum equation as possible, and then you draw the circuit. So you have this huge circuit. See? Okay, because this include the up and down counter. Okay, so do we have any question now? Faham ke tak? Do you understand how to do this?
Yes.
Okay, so now I would like to continue until we can finish this. Cascaded counters, key characteristic. Now, higher modulus count values can be created. So the Q naught of the previous flip-flop provides the input clock signal of the succeeding digital latch circuit. Okay, so divide by n, counters are built using these cascading handwriting techniques. So function is analogous to an asynchronous ripple counter. Okay, now look at two cascaded counter here. All J and K inputs are high. So this is not shown here because it's mentioned already. It's internally connected to high. So you can design here is modulus 4 counter. Okay, here is modulus 8 counter. So how do you know this 4 counter? Because you have two flip-flop here. Okay, 2 power of 2 is equal to 2 power of 2 is equal to 4. So this is modulus 4. And here we have 3 here. So 2 power of 3 is equal to 8. So this is modulus 8 counter. Okay, so timing diagram for the cascaded counter configuration in the figure. So you refer, this is the clock. Okay, so you look at here, this is refer to the Q naught bar, and then Q1 bar, Q2 bar, and Q3 bar, and then the last one is taken at Q4. Why you refer to this diagram here? Because here Q0 bar is connected to the next clock here, and then Q1 bar is connected to J2 clock here, Q2 bar connected to the clock here, and then Q3 bar connected to the last flip-flop here, and then the output is taken at QA. So that's why you refer to the Q bar. So this here. this timing diagram. So you only refer to the Q not or Q1, Q2, Q3, okay, at the negative age, yeah. Okay, so from here you get the Q4, you take at the Q4, so this is the diagram, the timing diagram. So this is equivalent to what? Modulus what you get? Here is 2, this is 8 already. Okay, so you refer here. It becomes what? Okay, at the end you get 32. Why? Because just now 8 and 4. Okay, so 8 times 4 is 32. So at the original clock here is at final 32. Okay, that is equivalent to 1 cycle here. Okay. Now this is modulus 100 counter using 2 cascaded decade counter. So decade counter is divided by 10, right? So now you have 2. So 10 times 10 is equal to 100. So this is modulus 100 counter. Okay, so this is connected to high and you have the clock here. Okay, F in here and goes here. Okay, because this is divided by 10. So the output here is divided by 100. And then 3 cascaded decade counters forming a divide by 1000 frequency divider with intermediate divide by 10, divide by 100 outputs. Okay, so because one of the circuit here is divide by 100, divide by 10, and then another second one is 10, so 10, another 10 become 100, and another one you become 1000, yeah. So if the clock input is 1 megahertz, you divide by 10, so you get 100 kilohertz at the output here. And then this 100 kilohertz, divide another 10, so we get 10 kilohertz here. And then 10 kilohertz, divide another 10, so we get 1 kilohertz at the final output here. Okay. So cascaded counter here determining the overall modulus of a cascade counter. To determine the overall modulus of a cascade counter, take each individual count value and multiply them together. So for example, you look at here, okay, there is OMV. What is OMV? Is the overall modulus value, is equal to mod 1 times mod 2 times mod n. Okay, where n is the next sequence modulus counter. Okay, for example, you have here, input goes in here, so counter divide by 10 here, 12 here, 16 here, and then you get the output. Okay, and then here, input the counter is 10, and then you divide by 4, divide by 7, 5, and so on. Then you find the output. What is the output here? You can calculate it. Okay, using the equation just now. Okay, so now this is creating divide by and counter using 74LS160 IC. Okay, so the 74LS160 digital circuit IC, that is decade counter, can be used to create divide by and counters. Okay, ease of data into the 74LS160 IC is accomplished using the 4 data input pins. Then IC makes PCB layout easy and save space. Okay, and then determining the frequency out of a divide by and counter. So how to determine F out of a divide by and counter? Okay, divide the input clock frequency by the OMV just now. So how to find the OMV? Okay, so you have F out is equal to F clock divided by the OMV just now. So OMV you refer just now from the previous slide. For example here, you divide by 100 counter using 274 LS 160 decade counter. Okay, so this is divide by 10, divide by 10. Okay, one decade. So this is decade counter. So this is the circuit. For example, you have clock 1 megahertz. Okay, what happened? This divide by 10, you get 100K, right? Output here. And then it goes into where is the input here? It goes in here. Okay, the output clock here, okay, is the divide by 10. Okay, so we get 10 kilohertz. Okay, we're finished. Finish. Okay, so now, hello, is everybody here?
Yes, Doctor.
Okay. Now I want you to look at this
I'm going to show how to design digital
YouTube,
logic counters using different flip-flops. Example 1. Design a counter
Can you hear it?
following state graph using T flip-flop.
Yes, Doctor.
First of all,
Yes, Doctor.
let's write the state table
Okay.
for the state graph.
Look at this, and this is good design.
These 3 columns represent the present state. And these 3 columns with the plus sign represent the next state. And these 3 columns represent the T flip-flops. The numbers here, like any truth table, are binary numbers ordered from 0 to 7.
Okay, wait. Okay, I prefer, okay, if you do the state table, you have this kind of table. Okay, you just list out 0, 1, 0, 1, 0, 1, and so on, and also 0, 0, 1, 1. Okay, why? Because then you won't do any mistake. Okay, for example, I've checked your lab report. Lab 2, I don't know why you did not arrange the bit like this. Okay, you skip the number. Some of you have 0, 1, 0, 1, 0, 1, and then you have 1, 1. You did not arrange in order. Okay, so I want to see this kind of table. Okay, we continue here.
Now let's write the next state. We obtain the next state from the state graph. So let's start with the state 0, 0, 0. 0, 0, 0. The next state is 1, 0, 0. So we write 1, 0, 0 in front of 0, 0, 0. So this is the present and this is the next state. Now let's go to 1, 0, 0. The next is 1, 1, 1. So this is 1, 0, 0. And the next is 1, 1, 1. Now for 1, 1, 1, the next is 0, 1, 0. So 1, 1, 1. The next is 0, 1, 0. And we continue like this until we fill all the table. We can see that the state 0, 0, 1 is not present in the state graph. So we just put dash, dash, dash. Now, to write the value for the three flip-flops, we need to follow this table. This Q represents the present state, and this Q plus represents the next state. And this T represents the value that we have to write in the T columns. Let's start with the TC. So let's look at the first number. We obtained this from the C here is 0 and the C plus is 1. So let's look at the table. 0 and the plus is 1. So we write 1 in the T column. Here we just have dashes, so we write X. We obtained the 0 from, let's look at the C here, 0, and the C plus is 0. So let's go to the table and see 0 and 0. We need to write 0, and that's why we see 0. And we continue like this until we finish the column. So TC deals only with C and C plus. Similarly, TB deals with B and B plus. And TA deals with A and A plus. As we can see, this is the full table. Now we just need to put those values in a K-map or kernel map in order to find the equations. In order to fill the K-map, we just need the values of the present states and the values in this column. Let's start with the first state, 0, 0, 0. We have 1. So CBA 0, 0, 0, we have 1. So we write 1. 0, 0, 1. CBA 0, 0, 1. We have X. So 0, 0, 1, we have X. 0, 1, 0, we have 0. So 0, 1, 0, we have 0. And like this, we fill all the blocks in the K-map. And finally, we write the equation for TC. And in the same way, we fill the K-maps for TB and TA. So this is the K-map for TB, and this is the K-map for TA. And these are the resulting equations. These equations that we obtained represent the inputs of the T flip-flops. This circuit diagram is obtained from the equations that we derived from the previous steps. We can see that we have 3 T flip-flops, C, B, and A. This input represents the clock. We consider synchronous operation in our design. TA, TB, and TC are the inputs of the flip-flops. The equation for TA was C plus B. So the C and B are inputs to an OR gate to give the equation of TA, as we obtained from the previous steps. These variables here, A, C complement, B complement, C, B, and so on, are obtained from the outputs of the flip-flops. So this is A, this A is the same as this A. And this is A complement, this is B, which is the same as this B. And this is B complement, which is this one and this one, and so on. Now we finish the design of the counter using T flip-flops. Example 2. Design the counter which has the following state graph using SR flip-flops.
Okay, now we have finished just now with the T flip-flop. Now designing with using the SR flip-flop, yeah? So look at this example.
We're going to follow the same steps that we used in the previous example. However, we're going to use this table the SL flip-flops, we have two inputs, SC, RC, SB, RB, and SA, RA. Now to fill these two columns, we need to look at C and C plus only. We have 0 and 1. Let's look at the table. When there is 0 and 1, we have 1, 0, and S and R. So we write 1, 0. In this state, we don't have any value, so we just fill with X's. Now in this state, we have 0, and the next is 0. So when there is 0 and 0, we fill S with 0 and R with X. So 0 and X. And we continue like this until we fill two columns. And in the same way, we can write all the values here. These two columns are related to B and B plus, and these two columns are related to A and A plus. As we did in the previous example, we need to fill all the columns in K-maps. And since we have 6 columns, we need 6 K-maps. So this K-map is RC, which is this RC. And this K-map is SC, so this is SC. In the same way, to fill this K-map, for example, which is RC, we just need to look at the present states and the column RC. Empty blocks here represent zeros. And this is the logic circuit diagram that we obtained from our design. This is the clock. Again, we have 3 flip-flops. This flip-flop represents the C flip-flop. This is the B flip-flop, and this is the A flip-flop. And these inputs are obtained from the equations that we derived from the previous step. As we mentioned in the previous diagram, this A, for example, is the same as this A, so actually it should be connected like this. However, we prefer to keep it like this for simplicity. We can design the digital counters using the JK flip-flops by using the same steps. However, we just need to use this table in our design. And to design using the flip-flops, we may use this table. Thank you very much.
Okay, do you have any questions? Dah tidur ke? Aiman?
Tak.
Amir, Sufi? Are you still around?
Ya, doktor.
Oh, buat apa sekarang?
Apa suka tengok video tadi, tengok video doktor lah.
Faham tak?
Faham?
So dia the same question you can design different using different flip-flop, yeah. So make sure you know how to do that. It's just that you have to refer to different transitions state diagram. Okay. Any more question? If you don't have any more question, then we take like 10 minutes break. Okay? Boleh?
Okay, doktor.
Boleh Akasha? We take 10 minutes break Okay.
Boleh, doktor.
So 10:20 masuk balik. Are you ready now? Is everybody here? Okay, now I want to check on the question that I asked you to do last time. Check your notes. The class is on the 26th of April. I asked you to design. Okay, implement a full adder circuit using 3 to 8 line decoder. Full adder. So have you done that one? Check your notes. Make sure you have done the question. Hello? Can you hear me?
Yes, Doktor.
Dah buat ke belum that question? Have you done the question?
Doctor, the question is the day you write on the whiteboard, is it?
You mean in the lab? No.
Yes.
No,
Oh.
not in the lab. In the class on 26th of April. Because I wrote in my paper here on 26th of April.
I haven't.
You haven't done?
Yeah. I just know got this question. I think I have done.
I asked you to implement because I think I wrote on the whiteboard on the computer here. Full adder. Check your answer whether you have done it. And the other question I asked you to do is implement the following function using 8 to 1 multiplexer. So the function is y equal to a, b, c, d, and then the function is 0, 1, 2, 5, 9, 11, 13, 15. Have you done that? Ada tak? Pergi tengok ada tak? Check your notes. And last week I gave another question. Okay. Mana dia? Tak ada pun. You want to send the whole question or only one question? Okay. Show me first. Which one? Whether I'm referring, you referring to the same question that I mentioned here. Ada tak? The size 5 will not over. Apa kecilnya awak ni? Mana dia? Nombor berapa ni? Number 4 and number 5. Number 4, implement full adder using betul, this one. Number 5. Number 5. Implement 8 to 1, 0, 5, 11, 13. Yes, correct. This is the one. Okay. These two. Okay, so how did you design it? Mana dia punya circuit? Warna hijau. Using marks, ya? So okay, D. So how do you do that one? A bar 1. Bukan ni sama ke? 1, 2, 3, 4, 5, 6, 7. 0, 1, 2. Apa tadi? 0, 1, 2. What is it? 3, 5, 11. Oh, 9 tak ada eh? 9 tak ada. 9 ada lah. You missing 9. Oh, tak letak 9. Lepas 5, 9. Okay, so your mistake is there. 9, okay, so 9 is there. So in the diagram there, you miss that 9 because 9 you did not circle, right? And then you have 11, 13, and 15. So you must have a bar and then 1. Okay, you correct that one. Hello guys, look at the WhatsApp sent by Syamimi if you have not done it. Siapa yang buat ni? Ada tak lagi siapa yang buat? Atau semua tak buat? Akasha buat tak?
Oh, yang tu doktor belum buat lagi.
Belum jumpa lagi ke? Wan buat tak Wan? Buat tak Wan?
Wan mana doktor?
Dua-dua Wan pun nama Wan kan?
What?
Awak buat? Lagi satu Wan buat tak?
Saya tak buat sebab tak jumpa soalan dia.
Awak tak catat ke 26 hari bulan? Bila awak masuk lecture tak tengok? Tak tulis tarikh
Tak, saya tulis kat buku je. Tak jumpa.
Tulis kat buku. Tak salin ke yang saya buat itu?
Salim. Tapi tak jumpa dengan benda tu kat buku. Ataupun buku tu dekat college kot. Saya tertinggal.
Okay, so Syamimi, look at the answer there. So the first one is A bar. Lepas tu, okay, after that 1. Lepas tu A bar juga. And then after that A. And then 0. And then 1. And then 0. And then A. Okay? So you can design using 8 to 1 marks there. So you must have 8 input there. Start with, you can label as D naught or I naught, yeah? Okay. So you connect like according to the table just now. Okay. So if your input you have A and then A bar you have inverter there and then connect to the input. Okay. So you have a select data that is B, C, D because you use A as the input. So you have output. Okay. The rest, do you understand how to design this? Hello?
Yes, doctor.
Okay, and then the other question is full adder. Look at full adder. So full adder, you must come up with the table. For full adder, that is for carry and sum. Okay, carry and sum, you look at the answer there. And then look at the carry and look at the sum. So you use 3 to 8 decoder. So the input is 3. Terminal that is A, B, C. For example, your friend has done here. Okay, mana dia my answer? Okay, so the output will be 0, 1, 2, 3 because 3 input, so you must have 8 lines there. So from 0, 1, 2, 3 and so on. So which part is connected, which number is connected to sum, which part is connected to the carry. So you look at there, you see the carry start from 0 is connected to carry, and then 1, 2 and here what? 4 and 4 4 connected to carry. Sorry. Sekejap, bukan. 0, 1, 2, 3. 3, 5, 6, 7 connected to carry. And for the sum is 1 connected to carry. 1 connected to sum. 2 connected to sum. And then what else? 3, 4. 4 connected to sum. And the last one, 7 also connected to sum. Okay. And yang mana tak connected tu 0 But you must have the ni. Syamimi, you don't have 0 here. Okay, you must have not 8 You don't have 8. You look at your output there, you have 8. You label as M1. Am I correct? You must start with M0. Or you just put 0. 0, 1, 2, 3, 4, 5, 6, 7. You must not have 8 there. Okay? So 0 is not connected to anywhere because both are 0, right? Okay, so you just leave 0 there. So then you have 1, 2, 3, 4, 5, 6, 7. Okay tak? So your design is not correct here. Okay? The table, look at the table. The table should be 0, 0, 1. The table is okay, except when you design this is not correct. You must not start with M1. You must start with M0. Okay? Okay, faham Okay, now look at the question that I asked you to do last week. Did you do that one? I think I asked you to submit, right?
That one done. Submit.
Done. Where did you submit? In Putra Blast
Yes.
Okay. So you draw the state diagram?
Didn't require us to draw circuit diagram, is it? Because one is the state table and the state diagram.
State diagram lah.
State.
Did you draw the state diagram? Not circuit. State diagram.
No, doctor, just now you say circle diagram.
Oh, circuit. No. You can draw the circuit, but it's okay if you finish up to circuit diagram.
Okay.
Not circuit diagram, state diagram. Sorry, state diagram.
I just do until state diagram.
State diagram. You did not try to draw the circuit?
Not yet.
Try to draw the circuit,
Okay.
Because this kind of question also can be asked. Because previously you start with the state diagram and then you state table and then you only draw the circuit, right? Find equation and draw the circuit. Okay. I can give the question like, I give you the circuit. I cannot hear you, Tan.
Sorry, doctor, what you say? No, just now my friend is talking.
Oh, because see, the question I ask you to do, I give you the equation, right? And then I ask you to find the state table and state diagram from there. Correct?
Yes, correct.
Okay. You can also draw the circuit, right, from the equation given.
Yes.
Okay. So in the test, I can ask you from the circuit, and then I ask you to go back, find what is the state tables, state diagram, and so on, right? So that's why you must know how to do that.
Okay, doctor.
Okay. So today you still have time. I want you to do this as your quiz. Okay. So next week we can. Rabu Wednesday we start a new topic. Okay. So this question. Okay. Look at your Putra WhatsApp. Dapat tak, everybody?
Yes, doctor.
Okay, design counter now.
Doctor, I want to ask the T flip flop. Can we do as the D flip flop since it is the same, right? Just the name.
T flip flop.
The T flip flop and the D flip flop is the same, right?
No, different.
Different.
Okay, so this question asks you to use T flip flop, yeah. So listen carefully. The state diagram is given in decimal number, right? That is 0, 2, 4, and so on, right? Look at the WhatsApp. Okay, so you change that to binary number. Okay. Draw the state diagram using the binary number, and then do the table, and then K-map, and then draw the circuit. Okay, I give you until 11:30 to submit in Putra Blast. Okay, everybody. Okay, see you next Wednesday. Okay, I dismiss, Okay, bye. Yang mana? Test tu bila saya nak share apa? Tu lah, saya ada cakap tak bila? Week 12 ke week 11? Saya tak ingat. Saya cari dalam WhatsApp tak jumpa pula. Okay lah, saya rasa week 12 kot. Because next week dah already 11, so I haven't thought about the test question yet. Okay? So study for week 12 lah. Okay? Okay, bye. See you. Buat soalan ni submit kat Putra Blast sampai 11:30 je tau saya bagi. Okay, bye.
Thank you, Doktor.
Thank you, Doktor.